Today we're going to be solving variables on both sides of the equation. This is definitely an 8th grade skill. I mean, it's even a college skill. So the first thing we have to do is talk about some steps. Now, not all these steps are going to appear in every equation, but there are steps you can follow. First, you want to clear the parentheses, if there are any. Basically, that means you're going to have to do the distributive property. Second, isolate the variable onto one side of the equation. Now, it doesn't matter if you take it to the left or take it to the right, but you want all your x's on one side and all your numbers on the other side. Third, you solve the equation. Fourth, you have to figure out, is there one solution, many solutions, or are there no solutions to this equation? Okay, so let's look at our first equation. 5x minus 2 equals 4x plus 1. In this case, there are no parentheses, so no big deal. So we go straight to isolating the variable on one side of the equation. In this case, I'm going to take my variables to the left. So let's divide our equation in two. And I want to move this 4x onto the same side as the 5x. But how do I do that? And what does it look like once it goes over to the other side of the equation? So how do I move things? Well, I want to take it away from the right side of the equation. So how do we take away 4x from the right side of the equation? Well, let's take away 4x. Just like subtraction, we're taking away the 4x. So if we take it away from the right-hand side of the equation, we also have to take it away from the left-hand side of the equation. So now I have, on the right-hand side of the equation, these two things will cancel out, and it leaves me with the plus 1. But on the left-hand side, let's see what happens. 5x minus 4x, well, that's 1x, or just x, minus 2. Now, are we finished? No, that x isn't by itself. We want to isolate it so it's the only thing left on that side of the equation. So how do we get rid of the minus 2? Well, how about if we add 2 to both sides of the equation? What you do to one side, you have to do to the other. And we'll get x equals 3. So the answer to this equation is x equals 3. There's just one solution to it. You want to check that? Plug the 3 back into the original equation. It would be what? 5 times 3, that's 15. 15 minus 2 is 13. Let's see if the same thing happens on the right-hand side of the equation. 4 times 3 is 12, plus 1 is 13, so both sides of the equation are equal. So x does equal 3. Okay, let's look at our next equation. Negative 2x plus 1 equals negative 4x plus 9. So our first step is we want to draw a little line to separate the sides of the equations and then ask ourselves which way we want to move our x's. Now here's the trick. You can move x's either way. You're still going to end up with the same answer at the end. Your work just might look a little different. So if you're trying to look at your neighbor's work and your work, sometimes it'll look a little different just because they've done the problem slightly differently. In this case, I think I'm going to move my negative 4x to the left-hand side of the equation. So let's add 4x to both sides. When we do that, on the right-hand side, we're just going to get 9. And on my left-hand side, well, negative 2x plus 4x, that's positive 2x plus 1. So now we just have a two-step equation. How do we solve it? Subtract 1 from both sides. And we get 2x equals 8. Divide by 2, divide by 2. X equals 4. Now you can substitute that 4 back into the original equation to make sure that both sides of the equation equal the same thing. In this case, if you put a 4 in on the left-hand side of the equation, you should get negative 7. If you put it back on the right-hand side of the equation, well, you also get negative 7. So that works. Okay, let's take a look at another one. Now this time, I'm just going to, for fun, move things to the right-hand side so that you can just see what it looks like when that happens. I've got an x on the left, and I want to move it to the right. So how do I get rid of this x on the left? Well, it's really 1x, so I'll take away 1x from both sides. In this case, I'll get negative 4 equals negative 6x minus 28. Now, how do I get rid of the minus 28? Well, I'm going to add 28 to both sides, and I get 24 on this side equals negative 6x on this side. Divide by negative 6, divide by negative 6, and you get negative 4 equals x, or some people will turn that around to x equals negative 4. Just depends on how you want to solve that. Now, finally, for our last one, hey, it's a problem with parentheses in it. What are we supposed to do first? We're supposed to clear the parentheses. And remember, that usually means do the distributive property. So we're going to distribute this negative 3 to both of these. So we get negative 3x minus 6 equals 9x plus 15. All right. And in this case, I don't know, I guess I'm going to move things to the right. Why not? It's kind of fun to do that. So I'm going to move my negative 3x to the other side. What do I do to move it? I have to take it away. So I'm going to do the opposite. This was negative 3x, so I'm going to add 3x to both sides. I get negative 6 equals 12x plus 15. Now, how do I move that plus 15? Well, I take it away by doing minus 15 on both sides of my equation, and I get 12x equals, in this case, that's going to be negative 21. So what I do next, I divide by 12, divide by 12. I get negative 21 over 12 equals x. If you're using a calculator, some of you will. I like the fraction version of this better. So I do need to simplify. So over here on the left-hand side, I'm rewriting the problem. And I get negative 21 over 12. I can divide both of those by 3. And I get negative 7 over 4, or negative 1 and 3/4. If you did it with a calculator, you should have gotten negative 1.75. There are two more video, or at least one more video, maybe two more videos on this topic where you'll find out about problems that have many solutions and no solutions. Watch them carefully because they do have a lot different meaning for their answers. All the ones in this one had one solution.